Dr. Fergus Clydesdale is currently the Distinguished University Professor in the Department of Food Science at University of Massachusetts Amherst and Director of the UMass Food Science Policy Alliance, which he formed in 2004. Dr. Clydesdale's honors and accomplishments in the field of food science and nutrition are legion and really too numerous to list, though I'll take a crack at letting you know a few of them. From 1988 to 2008, he was head of the UMass Department of Food Science, which holds a top ranking both academically and in student satisfaction, which is not a common combination. He sets a good example, apparently, as he is a recipient of the UMass Amherst Distinguished Teaching Award. He's published some 375 scientific articles and co-authored or edited 20 books. He received his BA and MA from the University of Toronto and Ph.D. from the University of Massachusetts. He served on numerous government advisory committees having to do with health, diet, and nutrition, as well as National Academy and Institute of Medicine committees, such as the one that we'll meet here tomorrow. His research involves the study and regulation of physicochemical changes in food, a process that alters the absorption of nutrients, food quality, physiological effects, food acceptability, and overall health and quality of life. And it gives a unique perspective, and this will lead us to his talk tonight, which is entitled A Nutritional Nightmare, From Famine to Feast, Why Science and Technology.
Thank you very, very much for the kind introduction, and I would like to thank the audience for coming out on such a terrible night. If I were you, I wouldn't come to listen to me. I really wouldn't. But thank you so much. I'm amazed, even in our town of Amherst, with 5 universities in the surrounding area, I don't think we would get this kind of turnout, and so I'm extremely pleased and honored to be here. A little bit about me just before we start, because I have a bias. I have a bias that technology properly used can do some good in mankind. I have that bias, and I openly admit it. I was brought up my parents were Scottish immigrants and came to Canada in the early 1900s, and I was brought up in a little town of 376 people in northern Ontario, and we didn't have water and we didn't have sewer, and I cut wood every day when I got home from school, and I had to carry oil in for a central oil heater. So I have a real love of technology. We built a back room on our house, and mistakenly I put in a wood burning fireplace, and I forgot what was involved, and 6 months later there's gas in there now, and so I've been through some of the problems without having technology. I've witnessed in the wintertime, not serious lack, but certainly a lack of fresh food, because in northern Canada, as in New England, there's nothing to eat in the wintertime if you can't grow fresh food. And so I've witnessed that, and I've witnessed my Scottish grandmother feeding me dried kelp. That's dried seaweed, for those of you who have had that, because it has iron in it. And in the springtime, you had to eat lots of rhubarb and whatever else grew up like dandelions to try to get some vitamins into you, So I've seen all that, so maybe that's where I got my interest in food and in food science and technology and nutrition. But I wanted to explain that bias. I don't have any disagreement with anyone who says that the food that tastes best is best for you and is the kind you should eat every day as often as you can is that's growing right outside your door in your backyard, and you go out and pick and you run it into the kitchen and you eat it. Without question. But how do you do that all year long? And that's the premise I hold tonight, is how do you do that all year long? In New England, I often tell my students that for me to grow tomatoes in New England in January takes about 2 bottles of scotch. Just in order to see them. One to plant them and one to see them. And so it's difficult to do. So we have that problem. So that's the premise, and I just wanted to explain a little bit about that before I started. Now, Michael Pollan, whom I had the honor of spending an hour with on an NPR show about 2 years ago, has written several books, and he's been extraordinarily successful. He's a great writer, very interesting guy, and he said food is what your great-grandparents ate, salvation from nutritionism, the reductive science of identifying nutrients and adding them one by one to food, And his mantra is eat food, not too much, mostly plants, which I agree with. Some reports in the press from some studies tend to vindicate this approach, but is it truly vindicated? And one must ask, how good were the good old days? And that's a question we always have to ask. There's a romantic notion in our society today that somehow or other, back in 1900, things were just perfect. And we were discussing this before the lecture, and there's a book called The Good Old Days They Weren't So Good. It's a wonderful book that points out life expectancy in Boston and New York was about 22 years. And, there was nothing to eat. There was terrible food safety problems. There was terrible sanitation problems. Things were not that good. So we have to look at that when we look back. Not to say that there's not a lot we can learn and take forward, but we have to look at the reality of the situation as we go forward. So if we look what we have now, we have a vastly increased life expectancy since our grandparents' days. We have extremely low amount of earnings spent on food, extraordinarily low amount, probably 10 or 11% of income in the United States, which is just incredibly low. In some developing countries, it's 80% of income. Extraordinary amount of variety, flavors, convenience, safety, and calories. Healthiest diets in the world are available. Note, I say are available. But wrong choices are often made to create an overall unhealthy diet. And that happens all too often. All too often. Maybe it's because we have too many choices. I don't know. Most people in the Western world can afford to eat as much as they want with a minimum of activity required in the process of living. And this is in contradiction to our genetic and cultural history. We are predisposed genetically to eat as much as we can when we can get it. So that next week, we can go out when we're out of food. We can go out and hunt something else and we'll be strong enough. We're not going to have it long. Back in the cave days, they didn't have refrigeration. They had no way to preserve their food. So you ate as much as you could when you got it. We're also programmed to rest as much as we can when we can. And so you take that problem of eating as much as we can when we can and rest as much as we can when we can, and you put it out and you say it's only going to cost you 10% of income to buy food, and you can buy as much as you want, and you can buy anything you want, and what do we have? We have a real problem. We try to defy the first law of thermodynamics. And the first law of thermodynamics says a change in energy equals energy in minus energy out. And that holds, and we try to defy it. We think somehow or other we can keep on putting energy in and not take energy out, and we'll stay static. And anyone who has a bank account knows that doesn't work. It works terribly, and what's happening is we're seeing this obesity increasing at an alarming rate. And so one of the things I want to talk a little bit about is that maybe technology has a role in helping this. Maybe not, but maybe it does. And then I want to talk a little bit about maybe technology has done some things for health, and then I want to talk a little bit about, towards the end of the lecture, what might it hold in the future? What kind of possibilities are there? This is a terrible trend. I mean, it's just frightening to see the trend that we have. It just continues to rise, and along with it, type 2 diabetes is increasing. We're seeing increases even in children that it used to be called adult onset diabetes, and now we're seeing type 2 diabetes in young children, and that's a shame, and we shouldn't be seeing this. Yes. Yeah. No, it isn't. No, we're not bad in Massachusetts. No, we're not that bad in Massachusetts. No, it's really, where you really start to get it is, in 2006. No, I think it's yellow. It's really pretty bad here, but I think there's a little spot, a little hope there that you can see. So, what do we do about obesity? Most people would say, well, we have to understand that we're challenging the first law, so we won't do it anymore. But we don't do that. We do things like this, stop overeating, spearmint spray yourself thin, and people buy this. They think there's magic bullets. And then we have Oprah, who has diet winners and sinners of the year, so we put all kinds of morality on losing weight or gaining weight, which is really difficult for people who do gain weight. And then we have concerns about obesity are reflected in a message from the Dietary Guidelines Advisory Committee report in 2005, which I was honored to serve on. They said calories count. We said calories count. We said eat more of some foods' nutrients and eat less of other foods' nutrients. Not very difficult. Not very difficult, but really difficult for people to do. Consume a variety of foods within and among the basic food groups while staying within energy needs. Control caloric intake to manage body weight. Be physically active every day. And this is really interesting. Note, once nutrient needs are met by food, once you get the nutrients you need by eating food, any excess calories can be obtained from fun foods. So once you get the nutrients you need, then what you've got left over for your needs to maintain weight, you can get from any food you want. Doesn't matter where you get them. And these are so-called discretionary calories. Anyone like to guess? Well, you look like very active people, but most people, you do. But most people in the U.S., would anybody like to guess how many discretionary calories they have once they get their nutrients? How many? 1,000? Okay. About 100. About 100. About 100. And that's doing a modeling study by getting the nutrients. We did the modeling study in 2005 by examining foods that of all the lowest calories. That is, of looking at skim milk, of looking at chicken without skin, of all the lowest calorie foods, and even with that. And the reason for that is because on the energy side of the equation, there's so little energy being used that there's no discretionary calories. And that's something that people just don't want to accept. And it doesn't matter the calorie source. They're all, if you eat too much food, you're going to get bigger. Your bank account gets bigger. So how do we get people to kind of deal with this problem? Well, we can do exercise. Exercise is a wonderful definition. The art of converting big meals and fattening snacks into back strains and pulled muscles by lifting heavy things that don't need to be moved or running when no one is chasing you. And I have to, there's a couple of slides in here. I have to give credit to Gary Foster, who's a good friend of mine. He was at the University of Pennsylvania and he's an obesity expert. He's now running a very big program in obesity at Temple University, and he's done most of the studies. He did the big major studies on the Atkins diet when they looked at that to see if it really worked. These major intervention studies, and Gary says that most interventions don't work. Once we try an intervention with people, we get a weight loss over about 12 months, and then the weight comes back on again, unless we have consistent counseling going with them. And this is one of the problems, is because we do have this wonderful definition. And this is another one, I travel a lot and I get into hotels and I'll ask when I check in, I'll say, they'll put me on the 5th or 6th floor and I'll say, where are the stairs? And the first thing they look at you is if you have some kind of perversion. that you're going to lurk in the stairs waiting for someone to come up, And they say, why do you want the stairs? And I say, well, I'd like to walk up and down to my room. Well, they call someone and they check it over, and once they figure maybe they're going to give you a room. And then they send you to the stairs, which are located at the back of the hotel, behind everything else, and you go into the stairwell and there's cobwebs hanging down and there's paint chips. Terrible experience. So we don't help this any. And the other one I love is, I don't know whether any of you noticed it, but when you go to work out, I noticed this when my wife go to work out, and you go into the parking lot and there's people drive around for 10 minutes looking for the closest place to the door so they can go and work out. It's just, boggles the mind. So what are the obesity drivers that we have in our society? Well, we have food intake, we have exercise, and we have the basal metabolic rate, which is what you burn off when you're not being active. And all those contribute to body weight. So your BMR is going to vary a little bit depending on how much muscle you have, whether you're male or female, how tall you are. Exercise, certainly, that last slide, goes into body weight, and food intake goes into body weight. And then if you look at the surround on all this is all surrounded really by what impinges on it is behavior. So we have behavior and we have these other issues, and how can we affect those? And please understand, I don't have the answer. I'm going to propose a couple of things that may or may not help, but I certainly don't have the answer. I wish I did. So behavioral factors must focus on dietary intake, and they have to focus on physical activity. Truly. They have to be both sides of the equation. And so one of the ways to do this is portion control. I mean, one is a 2 ounce and one is a 4 ounce, and one's going to have twice as many calories as the other. Unfortunately, this is what's most served in most places. And if we go in to buy it, if they're the same price, we're always going to buy this. And somehow or other, we have in our mind that we're doing ourselves a favor when we look at the cost calorie benefit. Somehow or other, the more calories you get for the less dollars is a good thing. It's just hard to imagine, but it is. I mean, you supersize everything. People think you're stark raving mad if you go up into a fast food place and you say, no, I don't want all that. But it's going to cost you 50 cents more. I don't care. I'll pay it. It's a lot of money, but I'll pay it, And they just think you're crazy. So we have to be concerned about portion size. I love this. It's simple. I have a shake for breakfast, a shake for lunch, and a rodent of my choice for dinner. And this is one of the things that my friend Gary Foster tells me, who is a behaviorist, who tells me is one of the few things that really works, is actually controlling signs, is telling people who have a weight problem that this is what you can eat and handing them a package of something that's defined. And that is one of the things that does work. So this isn't so far from the truth. So we have to begin to think of defining foods in packages and in amounts and in number of calories and in number of nutrients. We have to start thinking that way. And nature doesn't do that. Behavioral approaches that work best, again by Gary, attitudes towards obesity need to be scientific based, but often aren't. People think that there's magic calories and not magic calories. Individual level treatment creates significant health improvements, but the effects are typically not sustained. In fact, interventions are largely unsuccessful over extended times. Multi-level efforts are required, but the empirical support for such efforts is limited. So it's kind of something where we need a lot of help. And this is wonderful because it says here, with proper diet and exercise, my body should last a lifetime. So it's up to you to define the lifetime. A simple but often overlooked truism, which is what I'm getting at, is that the food and agricultural industries feed the world. And as much as I'm appalled at a lot of the marketing that the food and agricultural industries do, and they do terrible marketing, but I am aware of the fact that without the food and agricultural industries, we couldn't exist as we are now. One of the reasons for that is because we have such huge populations in the world today. We can't go back to eating just from locally grown stuff. We can't. We can help out, and I want everyone to eat locally grown as much as one can. It's healthy, it's great, but you can't go back to it. I think everyone should visit a food plant. I always give the example, just visit a plant that cans peas. I mean, they're not that popular. Everyone sniffing a hole. They're not popular. People don't like canned peas much. But there's pea plants all over this country. You go into a plant, they've got maybe 30 lines going. They're running off 1,500 cans a minute, 24 hours a day during season. And they got thousands of these plants across the country. And that's just keeping even with the demand for canned peas. Just keeping even. So, and then someone says to me, well, I got this 2-acre plot out the back. I'm going to grow enough stuff here for the cow. You got to be realistic. I mean, people should go and visit these things and see the kind of production that's involved just to keep even. So, what we have to remember too, and this is one of my favorite quotes, is the test of our progress is not whether we add more to the abundance of those who have much. It is whether we provide enough for those who have little. And in order to provide enough for those who have little, we have to maintain those cans coming off the line. We have to maintain food that's available all year long. We have to maintain food that people can buy at a reasonable price. And we have to maintain food that looks okay. Because if we don't, we're not going to provide enough for those who have little. Unfortunately, the stuff that we're providing for those who have little are often supersizes, are often things they shouldn't be eating, and are often things that they just pick up eating because they want more and more calories for less and less money. But we have to somehow or other get people to understand that technology can help to do this, but we have to have a huge educational campaign to go along with it to make sure that people use it properly. Now, Jim Hill from Colorado has a proposed solution. He feels the obesity epidemic is a result of a small daily caloric imbalance, and small behavioral changes are more likely to be successful and sustainable than major changes. And he suggests that simple approaches such as walking for an extra 2,000 steps, a mile, and or reducing intake by 100 kilocalories per day could really help. It would. Do you realize if you reduced your caloric intake or walked another mile a day, you would lose 10 pounds a year? Or you would not gain, or you would prevent yourself from gaining weight. The magic number is 3,600 calories. So 3,600 calories in excess will gain a pound. So if you do 100 pounds a day, you've got about 36,000 calories, which is about 10 pounds. It's fairly simple. So what if we could get technology in the food industry to close the energy gap by reducing portion sizes to 100-calorie packs, by reducing energy density of foods? A reduction in the energy density of only 5% would be equivalent to 100 kilocalories per day. And what if we could educate the public about the need to close the energy gap and to choose foods that have this reduced amount of energy and not eat double the amount of them? And what if we could get public-private programs that can communicate a consistent message from all sources? And I think this is where technology could be helpful. Where you could, if you could get the food industry to agree to begin to lower this, to get people to understand that processed technology foods aren't bad. Now, I'm amazed. I was at a meeting with USDA, and I had quite a bit to do with the USDA dietary guidelines, being on the committee. And I would get so frustrated because they would always say people have to eat more fresh fruits and vegetables. And I'd say, what's wrong with canned fruits and vegetables, which are much cheaper, and they're available all year long everywhere in the country? And what's wrong with eat more frozen fruits and vegetables, which are equally as nutritious, and they're cheaper, and they're available all year long everywhere in the country? And I even have the USDA, I have a hard time convincing them to even switch over to that. There's nothing wrong with canned foods. Many of us, my parents canned food all the time, and although the more I learned about food safety, the less I wanted to eat my mother's canned food. I must admit that. but I'm very, very optimistic about the technologically industrialized canned foods that are safe. So if we could do that, that would be really neat. It would be really neat to begin to lower the intake by 5%. It would be really unique. Now, if we wanted to reduce calories in foods, they can be reduced by displacing caloric components with ingredients of having fewer or no calories. We can replace fat, carbohydrate, or protein with water, air, or with molecules which are functionally similar but have fewer calories. Technology can do that. Technology can do that. So we have carbohydrate replacers, we have sugar replacers, we have bulk fillers, we have fat replacers, we have fat mimetics, low-calorie fats, fat substitutes. I was on the committee that approved Olestra some years ago. I chaired the committee for FDA that approved Olestra. It's not widely used because it got a terrible reputation for something that happened 30 years ago. It doesn't happen anymore. It caused anal leakage, which is not a very nice thing. And people just got used to the idea that it somehow was going to give them distress. But it's a good fat mimetic. So what can we do? Well, we can change fat. We can change fat by dropping it 32% or 92% or 79%. We can change calories by 6% or 28% or 57%. And remember, fat has 9 calories per gram, and carbohydrate and protein have 4 calories per gram. So fat is fattening because it has twice as many calories per gram as the others. We maintain an awareness of safety if we do this because we have to worry about increased water activity. Some things like salt and sugar that you put in food tend to keep the water activity down, which stops bacteria from growing, so we have to be a little careful. So there's an increased potential for microbial growth, but we can handle that. Now, the other dietary guidelines, aside from watching diet, and I want to go through these quickly, is eat more of some foods' nutrients and eat less of other foods. Why? Well, because if you have a shortfall nutrient, for instance, like fiber, if you eat more fiber, you can help this battle against type 2 diabetes. If you can lose weight and eat more fiber, it's helpful. We reviewed all the studies in the macronutrient report. The studies were enhanced. We found that excess fiber was protective against coronary heart disease, against type 2 diabetes, promotes healthy laxation, and helps with weight control. So why not eat more? In what food should we increase nutrient density? Should we supplement foods that people eat and perhaps decrease the energy density of those foods, or try to convince people to eat other foods? We have not been terribly successful at getting people to change their diets. Any idea how many fruits and vegetable servings per day we average in this country? Two. One of them probably is French fries. Yeah. So we haven't really done too well. So maybe people would say, well, you can't give up. Well, this has been going on for 30 or 40 years. So maybe there's some time when you got to say, well, let's look at maybe a different way. Maybe we should start trying to supplement some of the foods that people do eat with stuff that's good for them and take the calories down in those foods so that they get less calories when they eat them. Maybe. It's a thought. So, our favorite sources of fiber with additional fiber, French fries and rolls. Our greatest source of fiber from vegetables is French fries, and our greatest source of fiber from grains is rolls, hamburger rolls and hot dog rolls. It's terrible, but why don't we put in more fiber? I mean, if that's what people are eating and we can't stop them from eating it, unless we outlaw them, and I'm not for that, maybe we should think about supplementing them. Maybe we should think about doing something. Cooking the French fries as they're doing now. We've developed something in technology now that prevents the absorption of fat into French fries. So you can drop the fat by about 70%. It's absorbed into a French fry. So, I mean, there's ways to do these things if we look at them and admit to the fact, and God, as an educator, I hate to admit to this fact, that we have been underwhelmingly successful in convincing people to change their behaviors. We really haven't done a very good job. And I don't know how to do it. I don't know how to do it. I have kids coming up to me who say, at school, and I teach a large class for non-science majors, and they'll say, I'm gaining weight and I don't know why. And I'd say, well, why not? They say, I've stopped eating all processed foods. And I say, yeah. And I don't drink any sodas. And I say, no. And I say, how much juice do you drink? I say, about a gallon and a half a day. So do you understand how many calories are in a glass of juice? How much sugar is natural sugar? It doesn't matter if it's natural or added. Natural sugar is in a glass of juice. And they just say, no, I have no idea. It's good for you because it's natural. So I got to eat it. Huge numbers of calories. Huge numbers of calories. And so we have to be careful of that. The average fiber content of cereals purchased, look at what happened. Health claims advertising begins in 1984 when we could talk about fiber in food, and it jumped way up. But the availability of whole grains is only 11%, whereas 89% refined. But if we make flour blends with white whole wheat breadsticks, and there's white whole wheat flour now developed, versus red whole wheat, the kids accepted the white whole wheat much better than they did the red whole wheat. So why don't we start using whole grain and putting it into white whole wheat rather than red whole wheat, if that's what the kids are eating? But it's a terrible hard sell because people say, well, it just doesn't look like what I'm used to. Well, maybe you got to get used to it. What about nutrient fortification? We have a problem. When Margaret introduced the National Academy, she talked about the Food Nutrition Board that I'll be meeting at tomorrow. The Food Nutrition Board was formed in 1942, and the reason it formed was because when they drafted people to serve in the Second World War, they were so malnourished, the people they drafted, that they couldn't fight. And so they came to the National Academy and said, begin the Food Nutrition Board to develop minimum daily requirements for vitamins and minerals so that we know how much these kids should get. Hardly altruistic to convince someone, it takes a war to have someone say, well, we need to get these kids healthier because we want them to fight. There should be better reasons than that. But nonetheless, that's how it started. So, in 1924, we added iodine added to salt, so we don't have goiter, which is this big swelling under the neck. It used to be a goiter belt in the Midwest. Everyone had it. It became a sign of beauty. It was so big, a huge thing. And 1933, we added vitamin D to milk. Started to do away with rickets. In 1959, when I was in Canada, 1 out of 10 children suffered from rickets. 1 out of 10. And then vitamin D fortification came in completely and it disappeared. We're starting to see it again now, though, and that's one of the reasons for that is that moms are keeping their kids out of the sun, so they don't get any vitamin D change in the skin. 1940, thiamine, niacin, riboflavin, and iron were added to flour. Enrichment of breads began. 50s, standards of identity established for enriched and unenriched foods. 70s, proposed fortification of a class of food and specific nutrients. And then we had cereal grain folate. And I know all of you know that if you don't have dietary folate, you have a problem with possible birth defects. And you have to be taking the dietary folate before you're pregnant, not afterwards. So what they did is they put in pre-folate fortification and post-folate fortification. This was in cereal products. The dietary folate increased up here micrograms per day. The erythrocyte folate increased from 350 to 590. And if you can see the spina bifida, which is one of the birth defects you have, in pre-folate fortification, you had this many cases versus this afterwards, and this many cases of anencephaly afterwards. So a real big change, a really big change, noticeable change from fortification of foods. And it's better to fortify foods, in my opinion, than to take a supplement. Why is that? In my opinion, it's better to fortify foods because the amount is self-controlling. If a kid gets hold of a bottle of supplements, they can take a whole bunch of them, and supplements, like anything else, can be dangerous. Or if an adult says, well, one of these isn't doing me much good, I think I'll take 5, that can be dangerous. But you can't usually eat 5 helpings of food. If you try, you can, but it's harder to do. So there is self-control in there, some self-imposed control, which helps. Calcium intake trends from 1965 to 1966. Look at how they're going down. This was with decrease in milk consumption. Terrible. And then what happened is we introduced non-dairy calcium, fortified calcium, and the amount of total calcium is up 47.9% just from non-dairy calcium, but still low. So that's from fortification. And then if we looked at chilled orange juice sales, In 1987, Minute Maid made calcium rich, so we had this. Then Tropicana came in with a pure calcium plus, and then we had 10% of this was fortified, and 23% of the calcium we're getting now is from fortified sources in orange juice. Amazing, amazing, amazing. So food is a vehicle. We want to optimize bioavailability of all these compounds. No point putting them in if you can't absorb them. Provide a carrier to increase stability, minimize potential negative effects. The amounts consumed are self-limiting, as I said, and maximizes compliance. Product challenge is formulation, processing, stability, and sensory products. Food is a real engineering enigma. I'm sure there's lots of engineers in this room, and you spent all your career spending all their time making systems fail-safe. Well, food scientists must engineer systems that are guaranteed to fail. So we have exactly the opposite system. We have to have something that goes inside you and fails. That is, breaks apart so that you can absorb it. This ensures digestion and absorption, but where do we make them fail? We need a better understanding of the GI tract, and that's part of the new science we have to see. So, we have to design systems that somehow optimize breakdown to affect factors involved with food overconsumption, deliver nutrients, or confer more safety. We need to talk about whether we should eat your spinach, or we should identify, extract, and add bioactive foods to correct the effect of variety without variety. So maybe we can give variety nutrients without the variety, if that's what people are eating. We don't want to replace education, but add to it. We have to have physiological markers and a food matrix, create policy and regulations to advertise foods, and require basic and applied research tied to consumer education, and have revolutionary policy changes. Now, food is a vehicle. If you want to add things to food that make you healthy, for instance, I don't know how many of you are on statin drugs or how many of you take phytosterols from margarine or orange juice or something, but phytosterols lower cholesterol just like statins do. They're very effective. And they add them to orange juice. But their effectiveness equals efficacy times compliance. And this is something to think about. If you eat a food that has something in it, it not only has to work, it not only has to be efficacious, but people have to go back and do it again. It's one of the reasons drugs don't work so well, because people stop taking the pills. They're too big, they don't taste good, the medicine doesn't taste good, it's a pain, they forget it. So you have to have compliance. The best story I ever heard on this, and I'll tell it quickly, was a guy who was on the Canadian board to look at what should be done in physicals. And he's from the University of Dalhousie. And I was in Washington for a meeting, and there's a lot in the room about this size, but a lot of males, not many females. And he said, we looked at a lot of things in whether you should have them with your physical. And he said, one of the things we looked at was a colonoscopy. And he said, how many people in this room have had a colonoscopy? Remembering this equation. Because we know colonoscopies prevent colon cancer. We know that. So they're efficacious. But are they effective? That was what he was asking. Are they effective? So he said, how many have had a colonoscopy? And there's a lot of males over 50 in the room, so most of the room put up their hand. And he said, and how many have had a second? And nobody put up their hand. So, anybody in the room who has had a colonoscopy knows of what I speak. Compliance is really terrible because it's not a good experience. So, how do we get around that? So with food, you make it taste good so that people want to eat it more and they get it into them. We're talking about smart release molecules now in foods, and this is for the future. We encapsulate molecules to release nutrients where you want them in the intestine. So we can encapsulate them. In our department, we have a couple of faculty that are working on encapsulating molecules, and actually their technology is ahead of the biology. Because they're going to the biologist and saying, where do you want us to release these? Where do you want us to drop them in your intestine, Would you like them in the stomach or in the duodenum or in the jejunum or the ileum or down in the colon? Where would you like them? Well, I don't know, But we know there are places in the intestine where if you drop them properly, proper nutrients, you can actually affect satiety. So you can affect the feeling of fullness. You can actually affect the immune system, depending on where you drop them. So I see in the future that we're going to be doing a lot of this. What nutrients but we'll have to find out what nutrients we want to drop, what ones are important. We'll have to find out what it triggers. We'll have to understand the mechanism. Where do you want them released? And we'll have to have carriers to protect the bioavailable forms. So we can put them in here and we can have them drop because of acid enzymes or agitation or alkali or enzymes or bile or different release mechanisms. We can use food biopolymers and nanotechnology and do some really interesting things with that. We did some work in the department where one of our faculty took natural preservatives, natural antimicrobials, and put them into nano-encapsulated material and increased their effectiveness by a factor of about 100. Remarkable, you know, with a natural preservative. This is very interesting. We have another faculty member working on CLA. Do you know conjugated linoleic acid? Have you heard of that, CLA? It's got a lot of press because it some years ago was found in hamburger milk. It's naturally occurring. It's a trans fatty acid, but it's natural, so it's okay. So what it was found to do was it was found to prevent the risk of certain cancers. But another thing it was found to do when fed to animals, it changed the ratio of protein to fat in the body. So when you took this in, you got more protein and less fat. Wouldn't that be remarkable? We have a faculty member working on it now, and I just show this because it's impressive. I'm not going to explain it. But what it does, she's finding, at least in animal studies, that what it's doing is it's increasing calcium buildup and it's decreasing fat cells. Wouldn't that be nice? It's an animal work, so it's early in the day, but isn't that nice? Now, Michael Pollan says we're not supposed to do this because we're not supposed to look at reductionism. We're not supposed to look at little, certain parts of food. But if we didn't do that, we couldn't get these kind of ideas for the future, where we might have a mechanism to increase calcium, which is a huge problem. Huge problem. And we might have a mechanism to, at the same time, reduce adiposity. Wouldn't that be nice? We have probiotics plus prebiotics. Probiotics being the microorganisms in your gut, and prebiotics being the things that keep them growing. So we could have new cereal lines, or we could get them going well. We have found, in terms of probiotics, firmicutes in the obese, they think it's the ability to extract more. So certain bacteria in the gut are common in those who are obese, and bacteroides in lean individuals. Other bacteria in the gut are common in those who are lean. We don't know whether it's cause or effect. We don't understand that. We don't understand quite how it works. Some people think that it's just the ability to extract more calories if they're there, but I'm not sure that's true. Baylor found a significant decline in BMI, that is adiposity, among adolescents who were fed fiber, and the fiber allows the bacteria to grow. Now, this is a lovely site. I love this. This is in a recent issue of Food Chemical News. We have 10 times more bacterial cells than human cells. Just think about this. In your body, 10 times more bacterial cells than human cells. Therefore, we look like people, but we are really multi-species superorganisms, multi-species superorganisms. Bacterial genes exceed human genes in the body by a factor of 100. And they crosstalk with microbes and cells. And think about this now. The human genome is 90% identical. But we share only 10 to 20% of microbial species. So the differences between you and I are more likely due to what kind of bugs we got inside us than to what kind of genes we have inherited. And that's true. That's true. So the actual phenotype is probably due to microbiota rather than to our actually genetic makeup. And recently, and this just came out 2 weeks ago in Science, and I just want to, it's just really interesting to me. What they found is, and I'll really simplify this, but what they found is that these toll-like receptors are part of the immune system, so little receptors in the inside of the gut, and they're part of the immune system, and they felt they recognized flagella, the tails of bacteria, and when they did this, they gave signals to the immune system, and what happened is they began a low-grade inflammation, which caused insulin resistance, which can lead to type 2 diabetes, which increased appetite, which increases more appetite, and have positive outcomes of cardiovascular disease, type 2 diabetes, and obesity, simply because of what bacteria were in the gut affecting these toll-free receptors. And then the really exciting thing is someone decided to take some mice that didn't have toll-free receptors. They didn't produce them. And the same thing happened, but depending on the type of bacteria that were in the gut. So it was solely due to the bacteria. It wasn't even due to these things. It was just due to the bacteria, which was causing low-grade inflammation, insulin resistance, increased appetite, cardiovascular disease, type 2 diabetes. We're just beginning to understand that whole area of gut metabolism. And maybe that's been part of the changes, because the obesity has changed after the last 30 years. We didn't change our genetics 30 years ago. But we may have changed a lot of our microbiota 30 years ago because we do eat differently. We do eat differently. I mean, 2 servings of vegetables. I can remember as a kid screaming about having to eat so many vegetables, but I ate them. Because that's all there was, and you didn't get anything else if you didn't eat them. So we have changed. We have changed, and maybe that's got part to do with it. Green tea and catechins. There's some some interesting work there, particularly in China, that shows it impacts body fat metabolism, fat oxidation mechanisms. Who knows? Who knows? Maybe we'll get something there. But we need research on mechanisms, dose response, clinical outcomes. We need new and existing biomarkers. We need new food vehicles for bioactive ingredients. We need food composition and dietary intake data. We need more information on nutrigenomics. We need a lot of stuff. But what we want to do, finally, is interfere with this. Kelly Brunell from the Rudd Institute at Yale published this behavior chain. And I really like it. You know, you buy cookies, you leave cookies on the counter, you go home on Saturday afternoon, you're tired and bored, you get the urge to eat, you go to the kitchen, you take cookies to the den, you eat while watching TV, you eat rapidly until full, you feel guilty like a failure, your restraint weakens further, more eating. So you eat more cookies. So what we really need is somehow for technology to be able to break that chain. We have to build something that breaks that chain with satiety, breaks that chain somehow in the gut, breaks that chain somehow through taste, breaks that chain somehow through nutrients. We have to have something that breaks that chain. And if we can do that and we can add the proper nutrients to food, there is a place for technology. It shouldn't replace whole foods, which we should always eat when we can get them. But there is a place for technology, so the next time you read an article that tells you that technology and food processing is all bad, maybe just keep a little bit of an open mind and think a little bit about some of the things we've talked about today. Because, you know, it says, what is it today? I'm working on a lethal chemical that will kill cancer in the body. And he says, you know, sounds risky. Why not a nutrient that will prevent it? And maybe that's the answer. Thank you very much for your attention.